a go for engine start. 6, 5, 4, 3, 2, 1. Liftoff of Atlantis and the 6-man crew on a Department of Defense flight.
Today's advanced communications, exploration, and surveillance satellites and probes launched into space are extremely high-value items. They've often been called national treasures. Some are critical for national defense, and their value can't be measured in dollars and cents.
The Defense Support Program satellite has been deployed, nicknamed Liberty.
When a spacecraft is lost due to failure at launch or orbital insertion, the world notes and criticizes the government industry capability to perform our space program responsibilities. In these days of increasing pressure to get more value for each tax dollar, what's the best way to ensure space mission success?
There you see it, very smooth separation. We heard nothing and felt nothing in the cabin when that separated.
There's a variety of upper stages available on the market today for placing spacecraft into higher Earth orbit. But only one can claim a near-perfect mission success record after more than a decade of launches: the Boeing-built Inertial Upper Stage. Called IUS for short, this Air Force NASA upper stage can be launched from either the Titan rocket or the Space Shuttle. Over the last 10 years, it's proven to be the most versatile, accurate, and reliable launch vehicle in America's space program. It's flown, and the facilities and equipment are proven and in place. Facilities like the Boeing Space Center in Seattle, where the IUS is built. It's then transported in sections to Cape Canaveral, where all facilities and procedures for IUS final assembly, checkout, and transport for both classified and unclassified Titan and Shuttle launches have been proven through use over the last decade.
Up and running. 3, 2, 1, 0, and liftoff. Liftoff of the Space Shuttle Endeavour with NASA's newest tracking station in the sky.
When low Earth orbit is achieved, the spacecraft has completed less than 1% of its journey. Once the Titan or Shuttle releases the IUS and its payload, the IUS is completely autonomous, requiring no interaction with the ground. After release, the first stage ignites, providing the proper velocity for the 5-hour coast to geosynchronous orbit, 22,300 miles above the Earth. During coast, the IUS provides the spacecraft with power and can send discrete commands to activate spacecraft functions. It can provide active thermal control, using roll maneuvers to prevent constant heating of any one part of the satellite. It can perform pointing maneuvers to facilitate spacecraft communication with the ground. Upon nearing geosynchronous orbit, the first stage of the IUS separates, and the second stage ignites to put the payload into the proper orbit. The reaction control system provides the final adjustment for precision orbital injection. The IUS then separates from the spacecraft and maneuvers to avoid collision. With nearly perfect accuracy, the IUS has placed 5 TDRS communication satellites in geosynchronous orbit. 3 planetary probes have also been sent on their missions on schedule and with unprecedented accuracy. In May 1989, the Magellan probe was placed on a path to the planet Venus to map its surface. In October 1989, the IUS launched Galileo to orbit Jupiter and its moons for nearly 2 years.
The IUS was absolutely essential to get Galileo out of the Earth's gravity field and on its interplanetary trajectory. We had a beautiful ride. It was as close to perfect as anyone could possibly define. It just was excellent.
And in October 1990, Ulysses was sent to study the poles of the sun. The IUS has carried 6 military missions into high Earth orbit. The very first IUS mission was launched on Titan 34D in October 1982 and placed 2 defense and communication system satellites in geosynchronous orbit in separate locations. The 5 other DoD missions were launched from the Titan IV and Space Shuttle. The most recent mission was the Defense Support Program Missile Warning Satellite, launched in November 1991.
As you know, some of the missions the IUS flies deliver missile warning spacecraft. And I'd just like for a second for you to think about some Israeli families, some Saudi families that are alive today because of the good work you did on the spacecraft that's on orbit.
The IUS has been the workhorse for the Air Force since the early 1980s, and it has performed outstandingly for the Air Force. Each mission that we have flown with the IUS has put the satellite right in the desired location.
The unparalleled accuracy of the IUS surpasses that of the finest Olympic archer. Every one in the bullseye. The IUS has far exceeded mission requirements, eliminating the need to use spacecraft fuel for final adjustments, thus extending the life of the spacecraft. The reliability of the IUS far exceeds any other launch system. All spacecraft launched are operating in their desired mission locations. No other launch vehicle or upper stage has achieved such a record of success. What makes the IUS so exceptional? All critical subsystems are redundant to correct failures within milliseconds. These redundancies have been used to avert potential loss of 4 of the IUS missions, which saved the U.S. government an estimated $2 billion, a huge return on investment. IUS redundancy has paid for itself many times over. The IUS real-time uplink command capability is unique among upper stages. It saved the TDRS-A and can offer contingency options for future missions. The IUS design margins often exceed worst-case flight margins by factors of more than 2. IUS flight equipment uses the most reliable parts available. And rigorous testing is performed throughout development and at component and vehicle levels. Vibration and shock qualification levels are twice the expected flight levels. The IUS satisfies all NASA safety requirements for manned shuttle flight. There are no vented toxic, hypergolic, or explosive propellants, and no propellant loading is required in or near the orbiter. The inertial upper stage is fully developed and has proven reliable in all its missions. History teaches us much about the future. For more than 10 years now, the Boeing-built IUS has supported U.S. Air Force and NASA missions with unprecedented reliability and accuracy. And future IUS missions are being planned into the next century with the same confidence in mission success every time.